We are going to continue on from our previous lesson about solving linear equations. In these examples, we have some equations involving fractions, and then we'll also have some problems where we will look at the different solution types that we talked about in the previous lesson. Okay, so solve for x and simplify your answer. When you have a problem with fractions, there's a few different ways that you can approach it. I'll go over a couple of those in this lesson. So the first thing is, one way we can approach this problem is to move the 9 to the other side. Then we have 5/3 x, our term with the variable, equal to 15. Okay, so we have 5/3x is equal to 15. Okay, again, there's different ways to go about it. Notice how on the left-hand side we're dividing by 3, so we can multiply by 3 because multiplication by 3 and then division by 3 is 1. So if we multiply 3 on one side, we multiply by 3 on the other, and we have 5x is equal to 45. So that means 5 times what number is equal to 45, which would give us 9, or you can divide both sides by 5. Okay, the other way you can do this, we might not do the check on this one. We have 5/3x minus 9 equals 6. We have this denominator here. You can multiply by the least common denominator to every term. So for instance, whole numbers can be put over 1, as we've talked about, and so our least common denominator would be 3, so we can multiply everything by 3, okay? Multiplying everything by 3 is the equivalent of multiplying one side by 3 and the other side by 3. Okay, so here we would be left with 5x. Over here, 9 times 3 is 27, and then on the right-hand side, we'd have 18. Okay, so this gets rid of the denominators right away, and we can then add 27 to both sides to get 5x is equal to 45. So then again, we would get x is equal to 9. Okay, so there's a couple different ways you can approach this problem. Choose what makes sense to you and what's most comfortable. And if neither of those ways work for you, let me know, and I'm happy to meet with you to talk to you about maybe alternate ways, see how you're thinking about it. Okay, solve for x and simplify your answer. So with this problem, we have variables on both sides. We have different denominators going on. So I would probably multiply everything by the least common denominator to get rid of my denominators, and then we could solve it from there. Okay, so our least common denominator between 3, 6, and 2, it's like making equivalent denominators or same denominators like we did when we talked about fractions. Okay, so what can each be multiplied by to get to the same number? And what is that same number? So that same number would be 6, because I can multiply 3 by 2 to get to 6, 2 by 3 to get to 6, and this would just be put over 1 if you want to see it that way. Okay, so our least common denominator here is 6. So what we're going to do is we're going to multiply each term by 6. Okay, so 6 times 2 divided by 3. You can start to cancel now, or you can do it later. You might see that 3 goes into 6 2 times. But what I'm going to do is I'm going to multiply these together, and then I'll simplify at the end. So 6 times 2 is 12. We keep our denominator of 3, and then we have x. Minus 1 times 6 is 6. Okay, x times 6 is just 6x over 1. And then we have minus 30 divided by 2. Okay, when your x is off to the side, like it's written in this problem, you can just put it with the numerator so that you see where it is right away. Let's continue on with simplifying. So 12 divided by 3 is 4, so this is 4x. 6 divided by 6 is 1. 6x over 1 is just 6x. And 30 divided by 2 is 15, so this is a minus 15. So see how multiplying by the least common denominator really simplified it to an equation that didn't have any fractions at all. Okay, and then you would proceed to solve this like we did in the previous problems. So I'm going to move my 6x to the other side. Actually, let me combine the 4x minus x first. So this is 3x equal to 6x minus 15. Okay, and then I'm going to subtract 6x from both sides. So this becomes negative 3x is equal to negative 15. Okay. And then from here, negative 3 times what is negative 15? You might see that as negative 5. Or divide both sides by negative 3 to get x is equal to 5. Okay, we have just a couple of examples left. Example 9, solve for x and simplify your answer. So this equation has parentheses. I recommend distributing first. Okay, so we're going to distribute the 9 to the x and the 4. So 9 times x is 9x. 9 times 4 is 36. This is equal to, same thing, 3 times 3 is 9x. 3 times 4 is 12. And then we have plus 24. Okay, so now we have, 9 times 4 is 36, not 34. Okay, so now we have 9x plus 36 is equal to 9x plus 36. Notice how they're the same, and we'll talk about why they're the same, but let's keep going, okay? Let's move our terms with variables to one side, so we subtract 9x from both sides, and now we have 36 is equal to 36. That's true. 36 always equals 36, right? So because of this star and this star, your answer here would be all real numbers. This also means it has infinitely many solutions. And you might see this as negative infinity to infinity, which essentially means all the most negative numbers and the most positive numbers and everything in between. Okay, so you may have noticed that the 9x plus 36 equals 9x plus 36, whatever value of x you plug in, the left will equal the right. Or if you keep going and you get a true statement like 36 equals 36 or 5 equals 5, that's your cue that it's all real numbers. Okay? And then the next one, solve for x and simplify your answer. 3x plus 5 equals 3x plus 17. So let's start moving our terms with variables to the other side. So 3x minus 3x cancels. So now we have 5. This cancels. 17. Does 5 equal 17? And it's never going to. So this is a case of no solution. Okay, so you saw a lot of examples where we got one solution. Infinitely many or all real numbers is where we're solving it and we get something that's always true. No solution means we solve it and we get something that's not true. If you have any questions, please feel free to reach out to me.